Let's go through the next piece right now, and we're going to go over to linearity, intercepts, and symmetry. So we're going to go ahead and launch this one. I do want you to see, of course, how to do that. Eventually, I'm going to show you how to do it sort of like how a student would do it. But looking at the vocabulary, so how do we determine some things? So what is a linear function, a linear equation, an intercept, a line symmetry, point symmetry, even and odd functions? We'll go through that as we get through it. A linear function is just a straight line. That's all it is. A linear equation could be the same thing, but remember that it could also be a vertical line, which is not a function. A horizontal line is a function, so that's really just linear. When we're looking at equations in this particular case, so when we're looking at equations, we can see that x plus y equals 3 is linear because both x and y are to the first value. So that's a linear equation. X equals 4 is what is known as a vertical line. It seems kind of weird, but notice that x is equal to 4 everywhere. And if you look at where x is equal to 4, it's right there. So we'd have a line going that way. Of course, that cannot be a function because we can have no more than one y value. So we can't have more than one y value, so it makes it not a function. So, but it's still a linear equation. So these are both, this here is a linear function, both of them are linear equations. And then we look at other types of equations, anything that we're looking at, an intercept. So an intercept is where it crosses the, this is what is known as my x-intercept because it's crossing the x value. If I have another type of function like this one, and here's my lowest point, this is my y-intercept. Notice that none of these have an x-intercept. Sorry, my dogs always bark every time I'm trying to record a video. Sometimes I catch it and can stop it, but that's an intercept. Line symmetry just means if I were to draw a vertical line somewhere, is it symmetrical on both sides? So if I draw a line here, vertical line here, is it like a mirror image on both sides? And for parabola, yes, it is. For a line, it is not. And then there's something called point symmetry. And point symmetry just means if I put a point anywhere along here, so if I put a point here, is it the same on both sides of the point? Is it the same equation? And in the case of a line, yes, it is. So this would be point symmetrical. This one over here, this one would be line symmetrical. And we'll go through some other examples as we go through those. And then an even function and odd function. So what an even function says is if I plug in x equals negative x for a function, do all the signs change or do none of the signs change? So an even function, sorry, I don't have my good pen today. So an even function says no signs change. For an odd function, it means all signs change. Now, what does that mean? So we're going to get to that a little bit later on, but I'm going to show you here. So let's say that I have f of x equals x to the fourth minus 3x squared plus 2. And I plug in a negative x. So if I plug in a negative x, then I have negative x to the fourth minus 3 negative x to the second plus 2. Of course, anything to the fourth power, the sign's going to stay positive, so it's going to be x. This here, this sign's going to stay positive, so it's just going to be x squared, but we have this minus sign in front, so it's going to be minus 3x squared. And of course, there's no x here, so that sign just stays the same. Notice that all the signs stayed the same. So this is what? An even function. Okay? And then an odd function would be if I plug in, here's f of x equals 3x to the fifth plus 2x to the third minus x. And now I plug in a negative x. So I get 3 to the negative times negative x to the fifth plus 2 times negative x cubed minus negative x. So of course, this is going to cause a negative to come out. So I have 5 negatives, so it stays negative. It becomes negative. So I have negative 3x to the fifth. Because it's to the third, it's going to be a negative. So it's going to be negative 2x. And because this is a negative, of course, that's going to change that to a positive. So then I have positive, positive, negative, 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 positive. So therefore, this is an odd function. So notice that for an odd function, all the signs have to change. So if I were to have a constant, of course, and I try to plug in a negative x, that sign's never going to change because there's no x there. So anytime I have a constant, that's not going to be an odd function. And so we can go through, and we can check these as we go through them and see what those are. Okay, so that's what we have for those. Okay, so that's the definitions of all of those. Okay, so symmetry and functions. So how do we tell if it's line symmetrical or point symmetrical? That's what we're going to be taking a look at. So we're going to go through and just sketch some things and be able to see how things actually happen. So show reflection, show rotation. So we're going to look at reflection. Of course, reflection just means that here's my line or my mirror, and right across from that mirror, I have a point that's equidistant from A. Show rotation shows me that this is around a point. So here's my point in the center. Notice this distance here is the same as this distance here, and this point are now mirror images of each other. Okay, so we can see that for a line that it does not have line symmetry, but it does have point symmetry. Okay, and that's what we look at when we're looking at those different pieces there. Okay. So linear and nonlinear functions, it's important to understand the difference between the two. A linear function is just this ax plus, where is it? So it can be written as f of x equals mx plus b, or y equals mx plus b. That's a line. And remember that the important part about a line is this piece right here, is that if they are both to the first power and they are separate, then it's going to be a line. Okay, so I'm going to go through a couple more examples since they're starting to get into linear and nonlinear. But so for example, y equals 3x minus 2, well, this is to the first power, that's to the first power, so that's a line. Okay, no matter what, that's a line. What if I have something like this, though? What if I have y equals 2x squared minus x plus 5? Well, this is to the first power, this one's to the first power, but my highest power is squared, so this is going to be a parabola. What if I have something like this? X, y equals 5. Well, they're both to the first power, but we have to solve for y. So I have to divide both sides by x. So I have y equals 5 over x. And if you remember, may not remember this, but when I have something in the denominator and I move it up to the numerator, I put a negative in front of the power. So that means that y equals 5 times x to the minus 1 power. Now, this one's to the first power, that one is not. So it is nonlinear. Okay, so it has to be separated like that. And that's how we tell whether it's linear or nonlinear. Okay. So here we want to identify the linear and functions from equations. So this is going to be kind of what I told you about. So we'll have some questions here. So looking at this, here's my y. So y is always going to be the first in a function notation because that's the only way it can be, because y can't have multiple values. So y is to the first, x is to the first on the other side, or even on the same side. They're separated, so therefore this is linear. Linear. Notice that the square root of 3 is, the square root's only over the 3, not the x, so that's linear. And notice that this is y equals 5, which is a horizontal line. So, of course, that's linear, and that is a function, so it's going to be linear. Now, notice here we have y's on both sides, and we have an x here with a y, so I'm going to have to divide by x at some point, which means it's going to be nonlinear. And then this one here is squared, so therefore that's going to be nonlinear as well. Okay. Now, identifying them from graphs. Okay, so for identifying them from graphs, you can see here that it looks like this one here should be linear, okay, just because the way that it's kind of increasing. It's the only way that it can kind of handle going up, but you can kind of see it kind of has that same slope going on. This one is nonlinear, okay. This one's nonlinear, and this one would be linear as well. So it'd be A and D, as I've already marked up here. Okay, from tables, what we have to do is we just have to make sure that X and Y are going up the same amount each time. So notice that the X values go up by 1, so then we just check. This one's going down, but that goes down by 22, then it goes down by 22, then it goes down by 22, then it goes down by 22, so this one's definitely going to be linear. Okay, it just happens to be linear in the negative direction. Okay, so you're going to do a check. I'm not sure if this one is actually available or not, but you should be able to start ready to start doing some of the problems on this, and we'll go to the next video.